Today we are going to understand what is blockchain. So basically blockchain comprises of three key elements. First one is group of computers. Group of computers. Second one is cryptography. And third one is consensus mechanism. So here I have written the definition of the blockchain. Blockchain is a distributed immutable ledger which is completely transparent. Okay, so first let's understand this word by word. Blockchain. What is blockchain? As the word suggests, it is the chain of blocks. Now what are these blocks? So these blocks are the collection of transaction. Blocks are the collection of transaction. Now what is this transaction? So what we do when we transfer money from through phone, either we use upi id, or we use phone number, or we use the other person's account number, and we use that and we transfer the money to other person. That is one transaction, either through upi or contact number or account address. So here in blockchain web3, how this transaction happens, it happens from one address to another address. So anyone who is making transaction on the blockchain will have one address, public address. Using that address, the one person will be able to send any amount to the other person. So that is the transaction, and these transaction occurs through wallet. And in coming video we will deeply understand about wallet and also this address, how what is address made up of, what is private key and what is public key. For now we will understand that transaction is just sending money from one person to another person. Okay, and this block is a collection of those transaction, and this is the chain. Okay, now what we have to understand, blockchain is distributed. So let's suppose that this is a network. Okay, network of computers. So computers stay are connected in this network, and then we have this blockchain. So what happens, that this data in the form of blockchain will be with this one, this one, this one, this one, this one, this one, all the nodes that is there in the network. All of those nodes will have that blockchain. Okay, now it is a immutable ledger as the ledger. Why? Because of course it is the collection of transaction, that is what we call ledger. Now why immutable, how immutable? So I'll tell you why we call it as immutable because there is one thing. Yeah. So before understanding immutability, we will understand how these blockchains are, how these blocks are connected in a uh, is connected in a chain. Like how is it held together as a chain? So what is this? How is this happening? So let me explain it to you. If I expand a block, how does a block look like? A block comprises of block number. It is nothing but a data type. If you people are from computer science background, you will know there is one concept of structure where we can define our own data type, right? So data, and then we have here previous hash. We have here hash. So block number, let's suppose this is a block, this is block number 1 in data. Data is like all the transaction. In the place here we will have all the transaction from Ram to Arun, from Seema to Rima, like this. All the transactions will be here, this much amount and all those things from this address to that address. So this is how a block looks like. And now suppose this block is in the blockchain. Now how will another block come and get connected to it? So firstly, uh, this is, since this is the first block on the blockchain, we call it genesis block. Genesis block. And then what happens, we will take a hash of this block by running this block through one algorithm called SHA 256 algorithm. So let's suppose this algorithm is a kind of machine where we put in some data, audio file, video file, or a document file, or some data type. Then it will encrypt it and it will give us some very long number. Okay, something like 164 e e 7 a, like this it will be of, it is of 64 bits. Okay, so I'm going little bit technical, so I hope it is understandable to those who are not from computer science too. So this is the data is of 64 bits. Okay, and now what happens, once we get this we will have here. Okay, the hash of this block will be here, and previous, because this is the first block, in previous we will keep 0. And now when the another block will come here, same format will be here, like this. Block number, data, previous hash, and hash. So this hash will go here. So this is the thing that is creating uh, this is very important. Yeah, this and this will be similar, and this is creating the link between the two blocks. Similarly here we will have another block, and previous hash and this hash, like this it will get connected to the another block. So I hope you guys understood like how these blocks are connected among each other. Now let's discuss little bit about this SHA 256 algorithm. So this SHA 256 algorithm, what is its characteristics? So first thing is that it is one way. One way. That means if we put some data here through and we run SHA 256 algorithm through it, then we receive some 64-bit character, and it gets encrypted. So can we use this 64-bit character to get this data back? No, we cannot do that, and that is why it is called encrypted and it is safe. Okay, we cannot do that. What's wrong, man? Huh. Okay. Now, so what is the second thing? This is the first thing. Second thing is that it is deterministic. That means that suppose we have passed one data through SHA 256 algorithm, and that data is ABC. Okay, and it has given us, let's suppose it has given us U F7723 .44. Okay, this is one unique value for this data. And suppose we put in this ABC after 20 years through this algorithm, then also we will get this encryption only, this exact same. Okay, and if we change little bit thing also in ABC, like A B, only AB, if we remove C, then there will be tremendous difference between this data and the data that we will receive after the removal of C. So that means it is one data, one string, one input will always have one similar this one. It will not change, it will only change if the data uh, that is provided to the algorithm is changed. Let's suppose if we put if we had passed ABC through SHA 256 algorithm and we got 123. I'm just taking 123 for example. This SHA 256 gives 64-bit data only. So for example, I'm taking 123. So again, if we pass ABC through this algorithm, we will always get 123 only. I hope this is clear. Now let's move on to the third point. The third point is the most important point, that is, it has avalanche effect. And this is something that makes blockchain immutable. That means suppose one, I'll tell you. Yeah, I told you, like, if one this ABC is passed through SHA 256 algorithm and we got this data, right? And suppose we passed AB, if we pass just AB, there will be a huge difference. Let's suppose 7 9. Okay,